Hello everyone. So welcome to the second session. In first session of building agentic AI application, we discussed how the LLM inference works and how chatbot applications are implemented. But we didn't do the code hands-on, and we also didn't discuss how your agentic AI application gets the capability to do the things because your LLM is just a offline model deployed somewhere, which helps you with the reasoning part. But if you think about when you are using ChatGPT, it is able to do web searches. Same with the Gemini, it is able to use the maps. And when you are using some coding agents like Cursor, Claude, or Codex, you are able to see that it is able to read your code files which are in your local, and it is also able to write the code. So how these agents are able to do these things when your LLM doesn't have the capability to do this. So in this session, we will be covering that part. We will also be doing the hands-on for the coding of what we learned in or discussed in the first session and as well as in this session. So a quick recap of first session because we will be learning on the top of that. So just let me check. Okay, it is following up. So from the first session, what we learned is that whatever user prompt is going on to the system, to our agentic AI application. So there is a front end first, then front end sends that user prompt and session ID to the backend, and then the backend system, it tries to fetch that session from database, and then it returns to the backend whatever session history it got, right? And then it passes to the LLM this details like what was the system prompt, message history, and user prompt. And then your LLM application returns to the backend application with a single AI message. Then what you do as a part of the backend application is that you persist that message to that session ID for that session DB, and then you return the AI message content. So that's what we discussed. So far, what backend application has is just a session DB and a LLM, and this LLM inference can be deployed anywhere in the cloud that you're using. Like when you are using OpenAI API key, you're using the OpenAI LLM reference inference. If you are using AWS Bedrock, then that model is probably deployed in the AWS Bedrock by AWS team or about whosoever owns that LLM model. So you don't need to worry about those parts. What all you need is that that you are able to make a API call to that LLM inference, and what you need for that is a token because that LLM inference will do some authentication to identify you and to charge you for the tokens that you're using, and then they give you the response. So for the demo purpose, when we move to the coding session, we will be using DeepSeek uh, inference. And the model that we will be using is DeepSeek V4 Pro. You can use any model, whatever you want. It is up to you. I have the DeepSeek key, so I will be using DeepSeek key for the examples, and it has a knowledge cutoff of 2024. So that's what we discussed last time. So I will go into those details for now. Like when you go to ChatGPT or when you go to Gemini, you are able to see that those agents are able to perform the web search, or they are able to look into your emails. How do they do? So for that, there is a concept of tool calling. So far, if I talk about the applications that we discussed, basically these are not the agentic applications. What are agentic applications? Agentic applications are something which can perform some actions on the user behalf. So what we achieved so far, it is just a LLM call, right? LLM call is not equivalent to the is it doesn't mean that your application is a agentic application. For your application to be agentic, your application should be able to perform few actions, like it should be able to make web search, right? It should be able to perform few operations, maybe summarize your emails, summarize emails, right? Or it should be able to send the email, or it should be able to write code for you, right? Write code for you, or it should be able to book a hotel for you if you have used some model integrations, right? So these are the few things that you would have seen agents doing. Like it should be able to search hotels nearby, right? Or any kind of search that you want to do, right? So how to build this capability in your agentic application is that we are going to discuss. So far, this part remains same, that you have a user, you have a front-end application, user sends some prompt to the application, right? And then we won't talk about the session ID for now. Forget about that part because that part will remain same once you go there. So what your backend application gets is a user prompt, and then that user prompt and the system prompt is forwarded to LLM endpoint, and then your LLM endpoint responds with your AI message, which has content, and you return that message content to the front-end application, which your user sees. That's how LLM call works, right? Now, to have this kind of capabilities, let's say web search, summarize, or send email, what you need to do, uh, or what you need to have is basically inside your agentic application, you need to have functions. So there is nothing fancy about this. These are just the functions which you would have implemented by building your applications in whatever language, Python, Go, Java. It can be a function as small as like add two integers, int a and integer b, and it returns a plus b, right? It can be a function like web search, which takes some string query, right? And what it can do is, let's say you have some HTTP client. So the famous ones are, if you search, is like Serper, there's DuckDuckGo, there's Tably Search also. So I will talk about Tably Search because this is something which is optimized in giving the response, which are helpful for the LLMs, and they give few credits also on the sign up, so you can experiment around with that. So what this function might be doing is this is just pure Python function where you have your HTTP client and you are making a post call, right? Where you are giving the URL of your search or basically web search provider, and then you are giving the parameters or whatever body you want to give. And this is the response this must be returning, and what you return from here is that return the response, right? So these are the functions, basically an example of functions that you need to understand. So the first step is that you implement the function inside your application, right? Now the second part is that when exactly do you call this function and how do you decide this function must be called? So once you have these functions, or basically in the word of agentic AI, it is called as tools. Instead of function, you call them as tool. So what you do is when you are passing the system prompt and the user prompt to the LLM API call, you pass this additional detail which tells that these are the available tools that you have, right? So there is some metadata that you pass. What this metadata is basically list of tools that you have, and you can have multiple tools. If I talk about multiple tools, let's say if we talk about this one, so these are basically the tool details or tool metadata that you need to give. Like for tool one, what metadata you give the name of the tool. This name can be like add, and then there is some description, which tells the LLM what exactly does this tool do. Like the description is a string, name is also a string, because whatever metadata you are passing, this is a JSON that you pass to the LLM model. You don't actually send the function reference to LLM because your LLM cannot make a function call. This function, this is implemented here in your backend application, like function X, right? Your LLM cannot make a call to this. So what you're passing is just the metadata. We will come back to that part, how you that tools get in. So description can be like adds to integers, right? And what you need to pass is the arguments. What arguments does it take? You say this is A, this is B, this is first integer, this is second integer. So this is very similar to the document of a function or the function description that you write. Now for tool 2, similarly, you tell it the name, you give that name is web search. In the description, you tell that makes web search and return the references. There's some problem with my iPad today. Following up, okay. And returns the content and URLs. Okay. And then in terms of args, you tell there's a query which is of type string, and you tell that this is a user query. So there is just JSON metadata that you pass to the LLM so that LLM knows that what are the tools which are available in that backend application that is calling that LLM. And there are research papers, if you want to read, that LLMs can be trained for the tool calling. Not all the LLMs are good when it comes to tool calling. You need to search which LLM model suits. They are generally good reasoning models like DeepSeek, Viva Pro, or Gemini Pro. Gemini Flash might not be that good for function calling, so you can search what model works for you. And now coming to now, your LLM has been provided this inputs, your system prompt, user prompt, and the available tools. So what does LLM responds with? So LLM again responds with the AI message, right? Now this AI message has content, which we already talked about. And in addition to the content message, it also responds with a list of tool calls, which basically specify what are the tool calls that must be happening. So if I tell you in those terms, so tool call, sorry, uh, to, tool calls is again a array which comes from AI message, and this tool calls contains this details which tool call must be invoked, and it also gives the arguments that what arguments must be passed. Let's say it calls that call this function add, and the arguments first argument is 5, and it says the second argument is 7. That's what it returns. It also returns a tool call ID, which is some UUID. So in one response it can have multiple tool calls, and for each of the tool call that you get, now what you need to do here in your backend application is that you basically invoke those functions, right? You here in the backend application, you have these functions, right? So you make invoke the function, right? So you will get some response. It just bear with me for once. I will probably change the browser so it works better here. Okay, I'm back to this now. Um, okay, so your tools lie here in your backend application, right? As we just discussed, and this backend application can invoke the functions. And once the function is invoked, each of this function is responding something, if you see here, right? So the response that you get here, what you need to do with this response is that you again make a call to the LLM. Now what you pass here is that you keep maintaining a list of messages. So in this list of messages, so again here, always the input to LLM is a list of messages. So this time what goes as a list, first message is still the system prompt, which was sent. Then the next one is the user message. And the third one is the AI message that came, right? AI message, right? And what else is going here is the tool message. Whatever response came here as part of this function invocation in your backend application, you add those tool message. And how many tool messages are there? Is this just one tool message or multiple tool messages? So it is one tool message per tool invocation. Okay. So let's say you're asked to invoke both the functions, right? So you invoke both of them, you get the response one of the function, this addition function, and this another function, web search, it gave response to. So this gets converted into its own tool message. This also gets converted into all its own tool message. So each of these get appended here. So tool message for the first one, then tool message for the second one. Now, how LLM knows like which tool message corresponds to which tool. So when LLM suggested that it wants to make tool calls for these tools, it gave a tool call ID, which is a unique UID per tool. So when you're building this response, it has its tool call ID, and this one has its tool call ID, right? And since if you see here, we are passing all of them like AI message and tool messages. Each of them have their tool call ID, and AI message has details of the tools calls that it asks for. So that's how it is able to map which tool to be mapped to, basically which tool message gets response to which tool. So that's how those tools are invoked. It is not your LLM application which is actually invoking the tool. It is the backend application which invokes the tool. Your LLM application just tells like which tool it should respond to. So a clearer diagram is that this is your backend AI agent. It calls LLM. Now it returns with AI message. Now you check, does it ask for some tool call? Correct. Possible answers are yes and no. If the AI message doesn't have any tool call, that means whatever LLM has responded, LLM thinks that it had the sufficient information to respond to the user query, or none of the tool was relevant for it. So basically, LLM doesn't want you to perform any action. So whatever LLM response was that, uh, it is your final response, right? So this is where you stop. So if we go back, so what happened is your backend called the LLM, then LLM called your backend, you invoke the tool, right? Then you again call the LLM, right? So this is a loop. Backend calls LLM, LLM responds, then backend again calls LLM. So user hasn't gotten a response so far. When does the user get the response? So this is our stopping condition. Whatever LLM response is coming, if it doesn't have any tool call, then we just exit from the loop, right? So this is when your user gets. Otherwise, there's a tool call, right? Then what happens? It goes to your backend application. It invokes the tools, whatever tools are there. So if you talk about Cursor, Claude, or Codex, this kind of applications, the tools they have are like uh, read file, right? Or they can have tools like grab. The other tools can be like write file, correct. And since they are able to push to Git and all this, they might be having tools like read Git repo, right? So they are the kind of tools there. So once you invoke the tool, so now your backend gets the response, then your backend again calls the LLM, right? LLM gives the AI message. You again check whether there is a tool that needs to be invoked or not. If yes, you go back. So basically, this response is returned to backend application only. So backend application again invokes the tools, whatever tools are asked to be invoked. Right. So these loops keep going on, and it doesn't stop unless LLM gives no tool calling the response. And once there is no tool call as part of the LLM response, we just exit from this loop, and then that is the final response. Now there is one problem. What happens here if you don't have a guardrail? So this thing can run into infinite loop where LLM is continuously calling your tool, right? So what happens there is that uh, so on this loop, what you generally can add is a upper cap or upper limit of the tool calling. Again, stop. Okay, so there is a upper limit that you got to add. Okay, and exit. So this is one of the failure modes that you need to handle. Anyways, when you go and start implementing the agents, there are more failure modes that happen. So that's it in terms of the tool call, how your agentic application is able to invoke all these tools, even though the actual LLM, it doesn't have any capability or it doesn't have any other functions it can invoke, right? Because LLM is deployed somewhere in the bedrock or somewhere. So the way your cursor or cloud agents are able to write code is just by passing the information. They pass the information to LLM that this is what we have, this is what we are seeing, and what user is asking. So tell us what we should do. So LLM in its response tell that these are the tools that you should invoke. Those tools are generally either to get more information, or these tools can be to book something. Let's say here as a user you ask like book flight from Delhi to Mumbai. Okay, and LLM has a tool call where it can actually go ahead and it can make an API call to some flight booking system and it responds, right? So this tool call can be like any function, right? Or basically API call also. So basically whatever you can do inside a function in your Python application can be exposed as a tool to the LLM application. Anyways, let's go to some coding so that this part is clear. I think this part is difficult to understand. Um, let's move to the some coding part. So there's a GitHub repo there where I have pushed few of the notebooks that you can refer to. I'll probably duplicate this tab. So what you need to do is you just need to click on Open Collab and it will open. You don't need to um, buy any Collab subscription. This can be run freely. And this one is to cover the basic LLM code that we discussed in the previous session. So what you need to do is you just need to connect to the Python environments first. And what you need to have here is for this notebook, you need to have a DeepSeek API key. How you can get this? You basically go to the DeepSeek platform and there you can enable your API keys. Right? And there you can see the usage. You generally need to add few budget to it. I think adding $3 or $4 should suffice for doing a lot of experimentation because DeepSeek is very cheap API in those terms. It is not very pricier. So moving to the current implementation, if you look at the runtime, you don't need any GPU because this is just a Python application or Python function that we're going to run. We are not going to run any models in the local because we are using LLM inference. So first we install. So you will get this warning if you are running it through any of the collab notebooks from GitHub. It just gives a warning that you are running something from GitHub which you are not ordered. So if you trust the code, you can click to run anyways. So you can go to the code as well. Though the code I have added, it is fine and safe to run. Right. So why we are talking about OpenAI here is because we are using some of the frameworks. You will hear a lot about LangChain, LangGraphs. So these are the frameworks which help us save a lot of boilerplate code when it comes to implementing AI applications or making LLM code. And DeepSeek provides a OpenAI compatible key. And what a OpenAI compatible key means is that if you talk about the frameworks, they generally implement the constructs in terms of OpenAI compatibility or entropic compatibility. So if you're using a DeepSeek AI and you have written a code, there you can use any other OpenAI compatible key as well. And now the next code is to you import the key that I was showing here in the secret, right? So it has loaded the secret. Now, what we need to do here is that if you see from OpenAI, we import the OpenAI. This is just a construct which creates a HTTP client to make calls to the LLM ender mode. So since we are using DeepSeek LLM inference, our model is deployed somewhere in DeepSeek's cloud. And this is the base URL to hit it. And this is the key which it loaded. And we are initializing this client, right? So model is not specified so far. It is just a client that we are specifying. And this message retries refers to the retries in case there is some failure and then there is a timeout. So if I show you one plain call, so we discussed that a model takes a list of messages as input. And the first message we always pass is a system prompt. It is very small here. We are concise and helpful Python tutor and user message explain a Python dictionary in 2 sentences. So now you are making call to that HTTP client, and this is the function. Now this is just a wrapper over the post call because it comes as part of the client SDK. And here we are specifying the model name that we specified here is DeepSeek V4 Pro. And then we are passing the input, which are the messages. Then temperature is 0.2. You can set temperature anywhere between 0 to 1. 1 means your model will be more non-deterministic. It will try to randomly select some answer from top K, and temperature equal to 0 means is that it will always try to give the best match. So your answer is going to be less non-deterministic for a given model. And then there is some extra body. We will ignore that for now. It is just about thinking we don't need it for the current session. So we are passing those messages and we got the response. So now if you see assistant message, what we took from there is that response In the response, there can be multiple answers or multiple choices the model can respond with, and we are picking up the first one, and we are picking up the message content, a message basically from that, and we are just printing its content. So it says a Python dictionary is a built-in data structure that stores key value pairs, allowing you to quickly look up. Okay, so this is what it gives, and then there are multiple metadata fields which it gives. If you see response choices 0, we are checking the finish reason, and we are also checking the token usage. If you want to build some metrics layer, you will be able to see that. We'll ignore this for now. It doesn't make a lot of sense for this demo. But if you look at the token usage, it talks about the completion tokens, how many tokens were there in the prompt, right? And total is just a sum of the completion tokens in this, right? And a couple of other metadatas. It also talks about the cache hit or cache miss tokens. We want discuss the cache in this scope because there are ways to optimize the LLM inference call to save the cost, because your LLM model that is deployed somewhere in the cloud also does some caching. So let's try a couple of more prompts. This is just a wrapper function where you can pass some query or prompt. What it does is it just send that to the LLM. And here we don't have a system prompt, so it will probably assume some default behavior, like some useful assistant that, uh, though the recommendation is that when you're building some agentic application, you do specify what is a system prompt, because it defines the behavior uh, of your model. So the user prompt here was that give me one expected use of Python site. It returned with few user IDs, unique IDs, right? So you can read about this, but I will ask it one more question, like what was my previous question? So see, it says, I'm sorry, but I don't have access to your previous question because LLM doesn't have a memory of its own. That's what we discussed previously. Let's ask is one more question. What is the price of uh, iPhone 17 Pro Max? Because Apple hasn't released, so it says it doesn't have any information because Apple hasn't released or announced such a model yet. As of now, the latest iPhone model are say 16, which was released in September 24. So let's start. I'll ask this one more question, like what is your knowledge cutoff date? It can hallucinate on this one. So it is telling the cutoff date is January 2024, but in the previous mail just responded with some detail from September 24. But we can search on Google if we want. I will ask one more question from it, like what is the date and time today? The date and time today. Say I don't have the real-time information. Today's today date, you can check your device clock and what is the date today. Let's try to ask one more question. So again, say it doesn't have access to that. Cool. So that's how LLM call works. It doesn't have access to a lot of things. If I ask it, tell me latest news related to Elon Musk. So you don't have access to the real-time news. Okay, I think it is getting stuck on that now. But I think it has proven the point that LLM doesn't have access to the internet or other things. So let's move to the next one. I will duplicate again because once you click that, going back there takes time. So this notebook covers the part where we are using some in-memory uh, DB to store the session. So we will again install the dependency. It is connecting. I forgot to connect earlier. And again, we need to provide it the access to DeepSeek. It has the access to DeepSeek and it is installing the dependency. So each of the notebook that you will be running doesn't have the context about the another notebook. Probably this takes some random time, but not a lot of time. It depends on uh, how quickly Google is able to give your machine. Okay, and it's connected. Again, the RAM is 12 GB, 1 minutes of storage. Okay. Okay. It installed. It will now try to fetch the DeepSeek API key from the seeker. It's got it. Again, we will initialize our client to make calls to API DeepSeek, and now we have defined our system message here. A system message is you are a concise and helpful agent, and we are creating a local dictionary to store the message for a session. So we are using dictionary. We will be storing a list of messages against a session ID, and this list will again be a list of dictionary where the key is going to be the one who sent the message and like what is the basically whose message is it and what is the content. Basically, that's what you're going to store. So if you look at a sample entry in the dictionary, that is going to be, so you are going to have content and you are going to have role, and in some cases you might have more details. Like if a AI message is being stored, then it will have more details than just role and content. And now there is a get function which is implemented. What it does is it takes session ID as input and it returns the message for the session. If that session is not found in the session store, then what you do is you initialize this session ID and you return the message with the system prompt. So though we discussed that system prompt should never be persisted, for this example, to keep it simple, I'm storing the system prompt in the session. And if session ID is already present in the session store, then we are just returning the messages. So that's your in-memory DB to demonstrate how the session is being stored. Now there's a chat function which can be exposed through a fast API or backend API. What it takes input as input is session ID, then what is the user prompt, and then it responds with some message. So first step is to get the messages for that session ID from this session store, and then it creates the user message because when you are passing the input to LLM, it needs to be sent into certain format. And now what we do here is that we make the HTTP call to that LLM, and in the messages, what we pass is this user message and the messages, because first we had the message and we appended the user message to it. And then whatever response we got, we are taking out the first selection from there and we are storing its content right now. If you see, this is again persisted to the messages. And then we are returning the assistant message here. So if we run it, it's just a function definition, so nothing will be printed. Now, what we want to do is that we will start a new session, chat session, where session ID is some alias session, and like I can say my name is, let's say my name is Samanchu, and I build data pipelines. And then I will send it one more message. Probably I will remove it from here, and I will add a cell uh, below. So first uh, message, this is equivalent to the first call that we do. So what agent response there is that that's great so much to build in data pipeline. It's a crucial in the scale. It's a backbone of data-driven organization, right? Now, let's say if I change the station ID here, I ask what is my name, what kind of work I do. So your LLM is not able to answer that because there is no previous chat session. If we continue a chat session, so LLM should be able to get the previous messages. So you see, LLM is able to answer this in its mentioned you build data pipelines because this time LLM got all the messages history from there and the new user message, and that's what being passed to the LLM. Okay, so uh, one more example just to show, like if you start one new session, it again doesn't have any context of previous chat, right? And if I ask what was my previous question, what was my previous question, it will tell what is my name and what kind of work I do because that Bob session is already created. Tell me all the questions I asked so far. I asked. So all of this from the I'm sending will be answered within the scope of this session ID. So it is able to tell what exactly I asked, like what is my name, what was my previous question, tell me, okay. Now if I change the session, what does it tell? You see that? So okay, I have to copy it. Tell the questions I asked. Like, of course, here are all the questions. So they were just questions. The initial message was a statement introducing yourself, right? All right, so let's see what all happened in this session, what is stored, if you see. So in this session store, we are just printing the message that we have. Like first message was the system message, you're a concise and helpful assistant. Then there was a user message where I told about it. Then assistant responded with some details, right? And then there are the messages like user message, what is my name, what kind of work I do, it is able to answer that. Then you will tell me all the question I asked. Then this is what assistant responded with. So that's how you can see all the chat history, right? And then you can clear a session as well. If you want to clear a session in production, let's say. Okay, so that's it, how a chatbot works. So next we will move to the tool calling, which is the final notebook for today. I will open that as well in the collab. I will share the repo link so that you are able to run that. So this time we are going to explore how the tool calling works, and we are going to use Tably search as well. We will be using their API to make search calls so that our agent is able to make the web searches and is able to give the latest details to the LLM. And as part of this notebook, I need to enable both the DeepSeek API key to make LLM calls and then Tably API key to be able to search, make web searches. Okay. So now we will install the dependencies that we need here. And then we will import both the keys, DeepSeek API key and the Tably API key. Okay, now we will initialize the DeepSeek client, and then we will also initialize this Tably search client. Okay, where we pass the Tably API key. So this key is used for both authentication and the rate limiting the sums, like whether you have exhausted all the available tokens or available usage that you get. Now these are just two ordinary functions, just like how we would implement any functions in Python. The first function is Tably search, which takes input as a query, returns some string. And what this function actually does is it makes a HTTP call with Tably client.search where it sends this query. And then there are a few parameters it takes, which you can tune based on your um, use case, and then it returns whatever it got, right? And then there is a function document which has some metadata, like what does this function do and what are the arguments it take. Similarly, there is one more function which returns the current date time for a given time zone. So it resolves the time zone, then it resolves what is the current time, and it returns that. So these are just two functions. Very simple, very straightforward how you would implement them in a Python uh, code. Now let's try to invoke the date function that we implemented just to see that is so far it has nothing to do with the LLM or agentic application. It is just a function call that we are doing. We make call to the current date time with date time request, and the response that we get is printed. So the request is that I want current date time for this time zone, and it is giving the time correctly. Like it says 1st of August 1444, right? And that's exactly what this function is doing. Current date time takes time zone. Let's uh, try to invoke this function also that we had, like Java search. It takes query as input. What is the latest stable Python release? If you ask this, so if you see the request was this, what is the latest stable Python release? What is the latest stable Python release was the query, and then it shows the answer, uh, and then it also shows the results or the references webs that it referred to, and then here is the consolidated answer that it is giving. Now, if I ask this, when did iPhone 17 Pro launch? So it is able to give the details. iPhone 17 Pro launched on. There is not some AI or like agent LLM call. It is just a search call to a web search provider. Like there are more web search providers. If you see Serper, sorry, the Serper API, okay, for web search. Then there is one more DuckDuckGo if you want to search. So you can search for them. You know. So now you have the functions. That's what we discussed. Once you have the function, you need to provide the details of these tools or functions. Let's start with them as tools now to LLM. How do you provide these details to LLM is through the metadata that we discussed here. If I have to show you. So this is what we discussed, like you are passing the metadata of tools to the LLM. And this exactly what is here. These are the tool definitions inside array for each tool. We have a definition. Definition looks like this, like the type is function and the function has name, description, parameters, details like what parameters it take, like it takes query, it's a string, a focus web search query, and what are the required parameters. It doesn't pass any reference of the function implementation. So it is all just metadata, right? And then similarly for the another function, it just there's a current date time, what it does, what is the description for the params and what is required, right? So this metadata you need to pass to LM. But the problem with this is that this is a lot of boilerplate, and if you go write this, that's a work you will probably not write. So this alternate also like LangChain, as we discussed, it's a framework which helps us uh, extract out a lot of things into boilerplate code. So other way of defining these tools is that you define these tools using the structured tools from the function. So you have the function definitions. The important part is that you have this metadata details as well. So what happens here is that this structured tool from function is able to extract similar kind of uh, details that we need. Now we need to convert these tools in the tool definition so that they can be passed to LLM, right? And then this much code is doing that part, and then this is just the assertion to ensure that both of them matches, and then we will JSON dump the tool definition that got generated through here. So you need to convert it to the OpenAI tool definition so that your OpenAI compatible or OpenAI LLM understands the. So if you see this JSON that got generated by using this construct is exactly same as the function. There is a description. It has the properties for both the functions, right? Now we have our tools or functions implemented in our backend system. We have our metadata ready, which can be passed to the LLM. Now let's prepare the loop and the system prompt. The loop that I'm talking about is this loop, which happens here, and the one that we were talking here, that this loop, where your backend calls LLM, then tool call are returned, and then there is a invocation of the tool. Then your backend adds those as tool message to the LLM. Now the system prompt is that you are concise research assistant. Then we are telling it a couple of details about what functions we have and when to use. Though these details are not necessary because your LLM will get these details about the tools from the metadata that we are passing. But if you are implementing a very specific AI agent that you have, and the number of tools are going to be very limited, then this generally helps because it tells LLM that these are the tools that you want to invoke when it comes. It kinds of encourage or enforce LLM to suggest the use of these tool calls instead of just relying on the LLM thinking itself for it to decide which tools must be used. And then there are few guardrails like never claim that you search or check the time unless you call the tool, and when web search is used, use source URLs from the result. Okay, then there is one function. We'll come back to this function. Let's look at the loop that we were discussing. So run tool agent. So this is the actual React agent loop that we are going to discuss. So what comes as an input is the user prompt, and then this is a guardrail that we discuss so that we cannot, so we don't run into infinite loop. You define like what is the maximum number of execute or maximum iterations of this loop that can happen. So now you prepare the messages. In the message, initially you have the system prompt and the user input, as we discussed here, that you are going to have the system prompt and user prompt here along with the available tools. We will come back to the available tools because so far it is just the system prompt and the user message. Now we are starting our loop. Inside loop, what we do is we make a call to the LLM inference. Whatever we pass as input is the message that we have. We tell it what model we have, and this is where we tell that these are the tools that we have because we had to communicate it like what are the available tools. That's how you tell. And then there are a couple of metadata which are here. I won't go into the details because the main purpose of this part is to this session is to explain uh, how agents are able to perform actions. So using this input, URLM inference responds to the response, and whatever response was there, one thing you do is you add it to the messages first, as we discussed that we keep adding that to the list so that we can pass all the context to LLM next time, because when the next call goes to LLM, it should know what was the system prompt, what was the user prompt, and what did AI return, so that it can link to the tool message. So far, we have the AI response now, and now what we need to do is that we are checking if AI response or AI message had any tool calls in its response. And now what we do is that for each of the tool call, in the tool call it responded, uh, we are so far here are just printing. Okay, and now this was a printing part. It has nothing to do with the tool invocation. The important part is that in terms of execution is that if there are no tool calls in the AI response, then you just return with the message content, because if there is no tool call, then it means no other action is remaining, and LLM's response is the final response that must be given to the user. And if there are tool calls, then your flow will come here. For tool call in the tool calls that the LLM suggested. Now what you do is that for each of the tool call, you execute that tool, right? And whatever tool you get, tool result you get, you are appending it to the messages. And this message is basically a tool message, and the role goes as tool here, and here goes the tool call ID so that the LLM can map it to the tool calls it's suggested. And then here is the content of that tool result. This is just a tracing part so that we can print the trace later. But look at this part. It is your Python code, right? Exactly. It is not LLM which is invoking those tool calls. It is just passing the tool calls, basically telling what tools should be invoked, and it is actually invoked from this execute tool call function. If we come here, what exactly this function does, it takes a tool call as an input. So first thing to figure out is what is the tool name that LLM asks, and then you get the function from tool functions. If we scroll up, you will see we created this map here for a given tool name, which function needs to be executed. So you resolve the function here from the tool name, right? If there is no such function exists, you return that this tool is unknown, and then you resolve the arguments from the tool call function arguments which LLM has returned, right? And then you invoke that function with the arguments that are resolved, and that is the result that is being returned. So that's how each of those tools is being invoked. Right? So we'll run this. We have the agentic group, and the important part is that if already 6 of the iterations have happened and there's no response, then this will probably break. So you need to have guardrails around this when you actually code. You can have the guardrails, you can throw exceptions also if you want. You can have handling for that, and you can tune this number. This 6 is just for the reference. It will also ensure that your agent doesn't do a lot of tool calling, and it won't make a lot of LLM call, because for each iteration there is a LLM call that is happening. So there are tokens that are being used for each of the call. So let's run this function as well. This is just to print the trace so that we can debug what happened inside each of the invocation. So now let's run that function, run to the agent, and the function that you're going to ask is like, what is the current date and time in which you use the, I won't tell it in the user prompt because your user shouldn't know what are the tools available to your backend API, right? So if you see, as part of the metadata that we have been printing, so AI message didn't have any content. So AI message is being printed here, and the content is being printed here. Then for each of the tool call, we are printing this. So if you see, in the first iteration, there was no content, but there was a tool call. There was a call ID, and AI message had responded with this tool and the argument Asia, Calcutta, right? And then there, in the next iteration, AI message had this content. The current date time is this, and there were no tool calls, right? And if you look at the final answer is same as what was the content of the AI finally, right? So going next, so search the web for the latest major. Instead, what we'll ask is, what is the price of iPhone 17 Pro Max? Okay, let's see what happens for this. So in the first go itself, AI suggests two tool calls. One is the time zone UTC, another one is iPhone 17 Pro Max. So I think guess the year incorrectly. So it tried to make all these tool calls in the first go itself, and in the next time AI message contains this based on the current information here, iPhone 17 Pro Max prices, uh, and it is also adding few sources if you see. then there is a final answer which it is printing, right? So this answer doesn't probably seem to be right, even though the numbers might be correct, but the query was incorrect. It should have asked for 2026. Okay, so let's make one change to the system prompt to get latest web results. First, get the current date time to know the year and month. Okay, so what I'm telling is very similar to chain of thought prompting technique. Second, then use that time details to make web search. Let's make that change in our system prompt. Coming back to this example, what is the price of iPhone Pro Max? So again, it tried to, I will change this question. Pro, I think it might be some LLM, that LLM inference caching, which is leading to this. This is the price today. Let's ask it's differently. Still, it is going to 2025. So this is fine in those terms that LLMs are non-deterministic. This kind of problems need to be solved by better system prompts. So let's try one more. Otherwise, we want much to get later, like products, price, just you are a concise user, and depend on the tools and tricks for answering. So this will not change. These are need to be done. We change the question format so that caching doesn't kick in. Tell me the price of iPhone 17 Pro Max. They might be doing semantic caching as well. All right, so this time I think it worked. So the first AI message considered of content, I will look up. It had the content this time. If you see, I will look up the latest price for iPhone 17 Pro Max. Let me first get the current date time, then search for the most recent price information. So in the first go, it just made this tool call, right? And then the AI message that came the next time was with this tool call, where it asked to invoke this tool, table search with this query. So this time it was able to give the correct year, even though we didn't ask it to. Obviously, we didn't specify the year, so it is able to give the answers based on the latest detail now. So this is how I think the good that issue happened, that it was looking for the incorrect year, because it also gave me a chance to show how to debug why the overall response of your agent is coming wrong. So the base debug this is that what are the tool calls, what are the arguments that LLM is passing, because that way you will be able to improve your or fix your system prompts. So let's also try to print the tool trace. But will it give us an answer? This is the one. I will add code after that. Let's see. Okay. So the first one was this tool call. You to see it returned this part. Then the model came ahead. Sorry. So the model. So this is this one. Then the tool. Uh, got this query. iPhone 17 Pro Max, follow-up questions, null. Answer the iPhone 17 Pro Max started. Okay, so the tool gave few examples. I think that's it. So that's how you can add the tool calling to your agentic application, and you can now make your agentic application make API calls, do things, read files in the local, or retrieve some data. Like this website that we did is also kind of retrieval, where or more like a RAG, where you're doing the web search, where you are as part of the retrieval, you are retrieving something from the internet. Then as part of the augment, you are augmented to the prompt, and then LLM is generating through it. So that's how I think we covered some part of the RAG as well. So that's it for today. Let me know if you want uh, more detailed videos on the tool calling, or if tool calling was not clear, and comment in the comment section like what do you want to learn next for building agentic AI application. Thanks for listening to me.